Let's consider vertical translation, symbolically. Since we're adding or subtracting from the y coordinates on a graph, when we look at the function symbolically, f of x represents the y values. So in order to represent a vertical translation symbolically, we would just add or subtract that amount on the end of the function's expression. So if my function is f of x, and I want to translate it up by k units, I would just write a new function, f of x plus k. And if I wanted to shift it downward by k units, I would create a new function, f of x minus k. We can look at this in the example. Here I have f of x equals 2x minus 3, and I want to shift that function up 4 units. So I will create a new function that I will call g of x, which is going to be f of x plus 4 units. So the up 4 units part represented by the plus 4 after the f of x function expression. F of x is represented by 2x minus 3, so I can substitute that in for f of x. And then I'm just going to bring that plus 4 straight down, and then I simplify. So 2x minus 3 plus 4, I can combine the minus 3 and plus 4 to get plus 1. So my new function g of x is 2x plus 1. So let's try some examples. Write the symbolic functional expression that represents the stated vertical shift. Remember to give your new shifted function a new function name. I usually let my new function be g, but if you want to name it something different, you absolutely can. I want you to pause the video at this point and try part A on your own, and when you resume, I'll have the answer. Again, when you have these opportunities to pause the video and try them on your own, do just that. Try it and stretch your learning. Make a mistake, it's okay. See how much you've got with just one example, and then if you make a mistake, go back and correct it. For part A, is your new function 1 minus 5x? Great, good job. If it's not, check and see where the mistake happened. Go back and correct it. Let's work B together. In part B, f of x equals absolute value of x. So to get our shifted function, g of x is f of x plus 1, upward 1 unit. F of x is absolute value of x. We need to add on that plus 1 at the end. And this is our function g. G of x equals absolute value of x plus 1. There's nothing we can do to simplify this. We're just going to leave it as is. And then for part C, upward 2 units means we're adding 2. F of x is the square root of x. And we'll put that plus 2 on the end. We cannot simplify it any further. And so our new function g is square root x plus 2. Let's put these two pieces together, the symbolic expression and the graph. Here we have a function, f of x equals 1/2 x minus 1. And we want to shift that graph upward 2 units. So our new function, g of x, will be f of x plus 2, upward 2 units, plus 2. F of x is 1/2 x minus 1, and I'm going to add 2 to that, so I can simplify this minus 1 plus 2 into plus 1, 1/2 x plus 1. This is my new shifted function, g. Now the table for the shifted function, we have our new shifted function, 1/2 x plus 1. I'm going to choose specific values for x so that I don't have to deal with fractions. So I see that I have 1/2 times x. I want x to be even, because if x is even, then the 1/2 is going to cancel with that factor of 2, and I'll get a whole number. So I'll do a couple of these examples. I'll use the function and write all the steps out, but the remaining ones I won't. If you need to write them out, you absolutely can. So let's do -2, 0, 2, and 4. And I'll start out g of -2, 1/2 times -2 plus 1. 1/2 times -2 will give me a -1. -1 plus 1 is 0. So in my table, if x is -2, y is 0. I can repeat this with g of 0. 1/2 times 0 plus 1. 1/2 times 0 is 0. 0 plus 1 is 1. If I plug in 2, I'll get back 2. And if I plug in 4, I'll get back 3. Again, if you need to plug in those numbers in some scratch work, you absolutely can. Graphing our g of x function, -2, 0, 0, 1, 2, 2, and 4, 3. What I want to show you in this graph is that these points on the line that's already graphed here, this is a graph of f. Notice these points on f are being shifted up exactly 2 so that I get my new function g. And we can see that translation in the graph and also symbolically with adding 2 at the end. In the next example, I'd like you to try this one on your own. Pause the video, try it out, see if you can come up with the same answer. For part B, do your best. This cubic function has a lot of turns in it, but we can find 4 distinct points on that graph. And sure enough, we see that these points have been shifted down 3 units. Now let's look at number 3. Here we have a function f of x, and its vertically shifted function g of x, graphed in the same graph. We want to determine the direction and the amount of the vertical shift. So if I look at part A, my function f here is the solid darker line, and its shifted version g is the lighter line. So if I start down here with f intersects that x-axis if x is -2. And then how many steps does it take to get to g? 1, 2, 3 steps to get to g. And I went up. So this is an up shift by 3. And I can see that because the point -2, 0 gets shifted to -2, 3 on the graph. Can you try B on your own? See if you can come up with the direction and amount of the shift in part B. For part B, we can see that we have another one of those absolute value functions, the v function. If I take this vertex, the point in the middle where that corner happens, if I take that vertex at 1, 0, I see that it gets moved down by 1 to get onto the g graph. So I have down 1 for my translation, and my 1, 0 point gets shifted down to 1, -1. Let's look at the same idea symbolically. A function f and its vertically shifted version g are given. Determine the direction and amount of the vertical shift, and give a reason. The same idea here. Even though we don't have a graph, now we have the function. So how do we determine which way the translation happens? Well, I start with f of x equals 3x minus 5, and I end up with g of x equals 3x plus 1. I need to know, what do I add or subtract to the -5 to get 1? So I'm asking the question, -5 plus what number will give me 1? Or another way to look at this same problem is to take both of the function expressions, the new function minus the old function, and this will tell me how much I need to add to the old to get the new. So I could do it this way as well. If I do it using the whole function symbolic notation, 3x minus 3x, and then 1 minus -5, notice that my x terms cancel, and I'm left with 1 minus -5, 1 plus 5 is 6. If I look at it just in this smaller puzzle, focusing only on the constants, -5 and 1, I can also see that -5 plus 6 will give me 1. And since I'm adding 6, this is a shift up 6. The reason for the decision can be our very exercise that we did for the numbers. Try part B on your own, pause the video, resume, and see if you get what I get. In part B, this is a translation down by 4. In the next part of our lesson, we'll talk about horizontal translations.